And now for looking at some graphs, pictures of data. So this is done everywhere from first, second, all the way through 8th, 9th, all the way through high school, over and over again in lots of different ways. So we'll start with this example, these pretend scores on an exam. And one thing we could do is make a dot plot. So I'm not going to make one that's extremely accurate because it will take a long time and we've got quite a few of these to go. So what I'll do is I'll just go by fives. Let's see, it looks like the lowest score is 57. So I'll go by five. So 55, 60, 65, 70, 75, 80, 85, 90, 95, this would be 100. There we go. Now what you do is, on this number line, you just find the score, so 57, so that would be right about here, and then right above the number line, you put a dot. And then for the 99, that would be right here, and then a dot above 95. For 68, that would be right about here, 77, 73, 95. Now this is an important point. There's 2 students that got 95. So then you start stacking up the dots. So just stack them up. And if there's 3 students or 4, you would just make it go higher and higher, just stack up the dots. Then 81, 83, 75, 79. That would squeeze in right there. And 84. So that is a dot plot. Now the next kind of graph is called a stem and leaf plot. And it goes like this. So these are all going to be all the people that got 90s. These will be the people that got in the 80s, and then the 70s, the 60s, and the 50s. So for the people in the 50s, there's actually only this one person that got a 57. So you write it like this, 57. And this is called the stem, and this is called the leaf. And when you do this and there's more than one person, you do need to put it in order. So what I'm going to do is go through and do the 50s first. Done. Now what about 60s? So there's a 68. I guess I could look at this also. In the 60s, there's only one, a 68. So just put the 68. For the 70s, there's 1, 2, looks like there's 4. And I need to go in order, starting with the smallest. I believe it is this 73. So 73. And then after 73, it's going to be this 75. And next is going to be 77. And then 79. So then those are the 4 people in the 70s. And then for the 80s, there's 81, 83, 84. So 81, 83, and 84. And then for the 90s, there's 2 people that got 95. So you do need to write both of those. There's the 2 people that got 95. And there's a person that got 99. And then when I'm done, they're all crossed off and they've all been put in the stem and leaf plot. Now with this homework, they do give you a lot of the graphs and then you're supposed to interpret them. So for example, this one right here, number 5. So this is September 2001. And then this is the Dow Jones Industrial Average for the month of September. So this would be September 4th, 5th, 6th, etc., skipping the weekends. And then this is how much money it was worth. $10,000, a little bit more, etc. So does it appear that the average on September 5th, so that's this one right here, which that's just barely bigger than 10,000. and that's 500. Maybe that's 10,100. And then compare that to September 21st. So here is September 21st. And then it went down to, let's see, that looks like it's at about 8,200. So their question is, does it look like it's 8 times bigger? And their point with this one is that this picture is not drawn to scale. So if you look at this little rectangle right here, so make that just that size, and then keep it that size and go over here, and then it would be 1, 2, 3, 4, 5, 6, 7. I think that's what their point is, that this bar looks like it's 8 times bigger than this bar. But if you compare the numbers, is this number 8 times bigger than that one? No, it definitely is not. So the answer would be no, because this is not drawn to scale. To draw to scale, they should have started at 0, then 1,000, 2,000, 3,000, etc., up to 10,500. Then it would be drawn to scale. So next, they say compare September 21st to the 24th. So here's the 24th, and that looks like it's a little bit bigger than 8,500. I'm going to go with, I think that's 8,600. So does it look like it doubled? So again, their point is, if you measure this bar, this little one right there, and you compare it to the one next to it, so if you go across, then this one, this bar right here, looks a little bit more than double this bar. And if you look at the numbers, this one is definitely not double of this one. So that was their point. And why is the graph misleading? Again, because they should have started at 0, then go by 1,000, instead of, they skip from 0 to 8,000. So that means these bars are not proportional. And then if you take a look at number 7, the death rates in the United States, make a quadruple bar graph represented. Okay, let's take a look. So a quadruple bar graph. So we would have in the 1970s, so working with this column first. So in the 1970s, there was cardiovascular disease, so that goes up to 640. So let's say this goes 0, and then 1, 2, 3, 4, 5, here's 600, here's 700. So then for cardiovascular disease, then that would go up to 640. And it doesn't have to be perfect, but it should look like it's going up to 640. And then that is cardiovascular disease. Now, still working with 1970, for cancer, it goes up to 199. So right here would be 200. So for cancer, it goes up to 199, and that's going to be C for cancer. Accidents is 62, so this is 100, so 62 would be pretty small, and that's A for accidents. And then pulmonary disease, so that would be lung problems, and then that only goes up to 21, so then that would be pulmonary. And so then all of this represents 1970. And then to finish the problem, you would just go to 1980 and then make the bar graphs, the 4 little bars, then go over to 1990 and make the 4 bars, and that's how you finish that one. So number 9, there is this circle graph. When I was a kid, we called them pie graphs, but now they call them circle graphs. So what is the central angle of rent? In other words, how much is this angle right here? Well, if you go around a circle completely one time, that's 360 degrees, thanks to the ancient Babylonians. This is 30% of it. So if you find 30% of 360, so 0.30 is on the screen, times 360, that's 108 degrees. So the answer to part A, not 80, 108 degrees. That's like Las Vegas hot, 108 degrees. And then they say do this for the other ones. So you would just say for food, where's food? There's food. So it would just be 20%. So do 0.20 times 360. And then do the same thing for tuition and books. If the total expenses were $6,000, what amount was spent on rent? So if it's $6,000 total and rent is 30%, then just multiply by 0.30. And I know that 3 times 6 is going to be 18, so it's going to have an 18 in it. And then that would be $1,800 for rent. And then you finish by doing the entertainment and the clothing. And then let's see what else they have. So that was number 9. For number 11, this is called a pictograph. So to represent a car, they actually have this little green car right here. That's what pictograph means. It's a picture with a graph. About how many cars were sold in 1920? So that would be 1, 2, 3, and I would call that like 80% of a car. So 3 plus 4/5. So 4/5 is 0.8, or 3.8 cars. Now, of course, it wasn't 3.8 cars. It's just that's what they represent. Each car represents 50,000. So then we need to take 3.8 times 50,000. Oh, excuse me, 500,000. Tried to rip them off for some cars. So a 3.8 times 500,000. Let me see if I got enough zeros. Now I do. So that's a lot. How many zeros is that? 1, 2, 3, 4, 5. So put a 19 with 1, 2, 3, 4, 5 zeros, and then put commas. Whoops, that one was in the wrong place. So it looks like 1.9 million. Okay, then you do basically the same thing with those years. Suppose the graph was constructed so each car represents 1,000,000 cars. How would that affect the appearance of the graph? It would not affect it at all, because basically right now this is 500,000. So that means that each one of these would be twice as tall. But when you look at the whole picture, if you made all of them twice as tall, it would basically look the same. I guess it would look twice as tall, but it doesn't really affect the appearance. So then the cars sold in 1900, so that would be over here, was 4,000. 1910 is 181,000. What problem would you encounter trying to make a pictogram to include this? Well, 4,000, if each one of these little pictures is 500,000 cars, then to represent 4,000, what fraction is that? 4,000 out of 500,000. So 1, 2, 3, 4, 5. That means you would need to draw the car so that it was 0.008 of a car. So over here in 1900, you would have to draw 0.008 of a car. I think that's even too big. It would have to be smaller than that. So that's a problem. Oh, so this one right here, number 13, I read this. So these are the heights of females and males given in inches. And I read it a second time and I'm like, they forgot to put the question. Oh, but over here they say, do this for, so the directions are over here. Problems 13 and 14. Make a scatter plot. Okay, a scatter plot goes like this. So we're going to use the x and the y-axis. And this is going to be the female. And the y is going to be the males. And then for the females, we have numbers in the 60s and it goes up to 70. So I could start with 60, 61, 62, 63, etc. And then for the males, let's see, it starts at 66 is the smallest. So I could go 65, 66, 67, 68, 69, etc. And then for a scatter plot, you graph this as if it's x and y. So for the female, you go over to 64, and then the male, you go up to 70 and put a dot right there. For the next pair, it's 62 and 71. So go over to 62 and then up to 71. And then you just keep doing that. The next one, you go over to 66. So you go over to 66 and then to 73. So anyway, you then draw all of those dots. Identify any outliers. So an outlier would be, let's say that by the time you finish it, it looks like this. I'm not saying that is what it looks like, but let's say it looks like that. And then there's this one dot that's over here. So this one that is way far away from everybody else, that's an outlier. Now, if this was statistics class, then we would have a way to actually measure, like come up with a number and say, if that number goes beyond 10, that's an outlier. Here we don't have that. So you're just going to have to basically judge for yourself. So if the dot was like right here, I would say, no, that's not quite an outlier. It's fairly close to the group. But if it's way over here, that's an outlier. And then it says to use this E manipulative. That you don't have to do. And so this one again is going to be similar. So make the scatter plot, sketch the regression line. So the regression line means once you have the dots, and let's say these are the dots, and pretend this outlier isn't there, or it doesn't really matter if it is there or not, then you basically just make a line that goes through the middle of the dots. That's called the regression line. And it doesn't have to be perfect, it should just basically go through the middle of the dots. So this one is very similar to 13. And then number 19, the volume of all the types of mail. So first class mail, priority, express, etc. And then how many pieces of mail? What is the appropriate type of graph? So for this one, I would say that it would be a bar graph. So you would and then make that graph. Okay, so then I would say a bar graph. So then this would be first class mail. Sorry, here we go. This would be first class mail. Oh boy, the thing is this goes up to 100,000 and that goes up to almost 100,000. Well, since I already chose bar graph, this would have to be 100,000. And for first class mail, it goes almost to that, 97,000 something. And then for priority, so then this would be 50,000, like this is 10,000, 20,000, 30,000, 40,000, 50,000. So this would be 10,000. And then this is only 924. So it'd be a little tiny bar like that. So anyway, then just finish that graph, and that's number 19. And number 19 would be the end of the homework. So I hope this was helpful.